All right, question 18. In a ballistics test, a gun shoots a 340-gram potato, all right, into a 5-kilogram catching cart. The cart recoils at 3.7 meters per second after catching the potato. The first part was complete a momentum bar graph for the situation. I don't have a bar graph template set up here. I'll try to just kind of sketch one out. The event itself was an inelastic collision. The potato hit the cart, became part of this complex of the cart and potato, so this new mass would have its own velocity afterwards. What a lot of people kind of let slip was that over here on our initial, we had the potato was given at 340 grams. 340 grams, not a good unit. We needed kilograms, so 0.34. It had some kind of velocity here. Don't know what it was. So we had a momentum, and we could put it out in the positive direction. What else? We had the cart, 5 kilograms, and it was just sitting at 0, so it had no momentum. Afterwards, we're in the final part of this problem, we had this system of the cart and potato. So we had 5 kilograms plus the 0.34 kilograms. So we had 5.34 kilograms times something, which we're going to figure out here. But that would give it momentum, again, in the positive. A lot of what I saw, people tried to make it negative somehow momentum to cancel it out or something. But this thing already had momentum. The potato was moving, so it had some momentum. It just had to be the same over here. It wasn't going to cancel out. The only time that happens is if we've got a zero situation where we have zero momentum before and we have to have zero momentum when it's all said and done. That's not what we had here. The potato was moving into the cart. And so this cart potato mix over here should have the exact same momentum. It's got more mass here, so or less, more mass. So something's going to happen to the velocity there, but we can figure that out. The momentum conservation equation. When you see a question that asks for the equation, that's all they want, just the equation. So for this one, it was going to be m1 v1 plus 0. This 0 is coming from there, the 5 kilogram cart times 0 velocity, equals our good old inelastic collision formula, m1 plus m2. That is right there, the cart potato complex, times v2, or in this case, the velocity afterwards. The question then went on and said, determine the initial velocity of the bullet. The initial velocity of the bullet then would be, plug and chug, 0.34 times v1 plus 0 equals 5.34 times, 3.7. I should have put that in up there. 3.7, because that is given in the problem. 3.7 right there. So now we just solve this through algebra. We multiply these two together, and then we divide this product by 0.34, and we get a V1 of 58 meters per second. No matter how you look at it, that was one fast potato.